Hello viewers, in this video we will see the solution to week 1 assignment 1 for the course Introduction to Machine Learning. So first question, which of the following is slash are unsupervised learning problems? So Introduction to Machine Learning, assignment 1 solutions. These are our suggestions. Kindly spend time in going through the solutions before or after assignment submission to get better score in the exam. Later you may not find time, you will be very busy with record submission, assignment submission, preparing for the end semester examinations. It's better to spend few minutes, maybe 5 to 10, 10 minutes, 10 to 15 minutes in going through the steps of these solutions. Okay, first question. So it is about unsupervised learning. So it is nothing but discover patterns in the data. Two types, clustering and association is there. So the options are A and D. So option A, sorting a set of news articles into 4 categories based on their titles. And D, identifying close-knit communities of people in a social network. We'll move on to the second question. Which of the following statements about reinforcement learning is are true? So second question, reinforcement learning, learning to control, that is learn from close interaction. It is from the stochastic, environment is stochastic, and noisy delayed scalar evaluation. Learn a policy. In this, maximizing a policy, maximize a measure of long-term performance. So here, as per the definition of the statements of reinforcement learning, so the answer you can see here for 2 is D and E. D and D. RL agents used for playing turn-based games like chess can be trained by playing the agent against itself. Self-play. RL can be used in autonomous driving system. Third one, which of the following is a regression task? Third one, we can see, so regression, here it comes under supervised learning. So we have classification type, which is categorical output, and the other one is regression, continuous output. So the answer you can see, third one is option B and C. Option B and C, predicting the number of COVID cases in a given time period, and then predicting the total number of goals a given football team scores in an year. Fourth one, which of the following is are the classification tasks? Just now we saw the classification task. So classification task, it's categorical output. So you can see the options for fourth. Here is A and D. A and D. So fourth one, predicting whether or not a customer will repay a loan based on their credit history. And C, D, predict if a house will be standing 50 years after it is constructed. So A and D. Fifth one, consider the following data set. Fit a linear regression model of the form. So they give an equation y equal to b naught plus beta naught plus beta 1 x1 plus beta 2 x2 using the mean squared error loss. Using this model, the predicted value of y at the point x1 comma x2, that is 0.5 comma minus 1 is. So it's a very lengthy problem. Step 1, define x and y. So x is a vector, x1 and x2. We have taken a dummy variable x0, which is always equal to 1, and for corresponding x1 x2 we have outputs also. So step 2 is, we have taken the given data, excepting is x0 we have taken as all ones, which is not given in the problem. Okay, step 2, compute A inverse. What is this A inverse? A inverse is x transpose x whole inverse. So this is nothing but A inverse. What is this A? A is simply nothing but X transpose X. A is simply nothing but X transpose X. So we will first try to compute A and then we will try to find inverse of A. So what is A? A is X transpose X. So we know what is X. So that is X is nothing but here we are given this is X. This is X. This is X 6 cross 3 matrix. 6 cross 3 matrix. Here I am again repeated here X. This is our X which is repeated here. And X transpose of this X. Transpose of this X. You know matrix transpose. It is this one. So we have to multiply these two. So I have written here entire row wise I have written row 1, row 2 and row 3 multiplication and the addition of those for row 3 cross 3. So we get A is equal to 6, 0, 0, 0, 12, 6.5 and 0, 6.5, 5.5. From this I can find A inverse. So I have not shown the steps to find how to find the A inverse. I have directly calculated. So A inverse will get these 9 elements will get A inverse. So again it will take a lot of time if you show here. So I have directly found written here A inverse. Step 3 is to find B. So what is this B? B is X transpose Y. So we know what is already X transpose, it is here. We also know what is Y. This is our Y. So X transpose is this one. So X transpose. This is our X transpose and this is our Y. This is our Y. So X transpose Y, again we multiply these two. So again multiplication I have directly computed the multiplication of these two. It is 5.5, 5.95 and minus 1.275. Okay, after computation of this B, we will try to compute beta. So this beta is again a vector, we know. So beta is X transpose X inverse and then X transpose Y. So this is nothing but our B and the entire thing is our A inverse. So we already computed A inverse and B. So we will simply multiply these two. We simply multiply these two. We will get here 0.9185, 1.73 minus 2.28. Now once beta is obtained, step 5 last, Y is equal to beta naught plus beta 1 plus beta 2. So 0.9185, it is 0.92, it is beta naught. So this is beta 1 and this minus 0.2.28 is beta 2. So substitute. So they have given x1 and x2. x1 and x2 is given. So x1 and x2 you can look at the problem. So 0.5 is x1, x2 is minus 1. Minus 1. So 0.5 and this is minus 1. So compute this, you will get 4.06, which is because we have rounded off the numbers, we are getting slightly higher. So approximately it is 4.05. Option A. The answer is option A. Sixth one, consider the following data set using a k nearest neighbor regression model with the k equal to 3. Predict the value of y at x1, x2. Again, here it is 1.5. Use the Euclidean distance to find the nearest neighbors. Use the Euclidean distance to find the nearest neighbors. So sixth one. So Euclidean distance formula is square root of x minus x1 square plus x minus x2 square. Okay, where x, but we will only compute, not the root, just we will try to find x minus x1 square plus x minus x2 square. For comparison purpose, it is enough. And the test point they have given is x1 comma x2. This is 1 and this is 0.5. Here this is our x here and this is another x will be here. We will substitute. And they also given k equal to 3. So what they already given x1, x2 and y value. So I have already written here, and let it be serial number 1, 2, 3, 4, 5, 6. So what according to this formula, we will computing the d1 square, which is serial number 1, d2 square. So now d1 square, let me compute d1 square according to this formula. So according to this formula, this is 1 So 1 minus 1, 1 minus 1 here I have written, and then 0.5 minus 0, square it, you will get 0.25. Similarly for d2 square, 1, here it is 1, minus of minus 1, minus of minus 1, whole thing is square, and then this 0.5 here taken here, and again this 0.5 minus 0.5 is taken here. Again square of this, you will get 4, you will get 4. Okay, so you will get 4 here. So here minus 1 becomes 2, 2 square, 0.5 minus 0.5 becomes 0, it is 0 square, it is equal to 4. Likewise you can compute for d3, d4, d5 and d6 square. So I am getting values 0.25, 4, 1.25, 13, 0.25 and 6.25. So out of these 6 values, so I have to choose 3 least values. 3 least values. So those 3 least values are 0.25, which is for serial number 1, and correspondingly y I have marked. And next is 0.25, which is d5, which is nothing but serial number 5, I marked here, and also I marked the y value. And the next least little higher value is 1.25, so that is serial number 3. The corresponding y is also marked. We have to, because k is equal to 3, we will consider only the 3 nearest, these are the 3 nearest values. Now we have to take average of these 3 values. So here 2.65 plus 1.95 plus 1.95 plus 0.6 whole divided by 3. This is an average. It is an average. So we will get 1.733. So the answer is 1.733, option D. 7th one, consider the following data set with the 3 classes 0, 1, 2. Okay, and there are k equal to 5, k equal to 5, k equal to, here k equal to 5. So we have to predict the class label for at this point. Again use the Euclidean distance to find the nearest neighbors. So for this problem, so what we'll do, so 7th one, we'll now k is equal to 5, test point is 1, 1. Again we'll use the same d square formula. So the method is same. So here the test point is 1 and 1. So therefore come to this, so 1 minus of minus 1, this one here, and then this one again, this one again is coming here, and then minus 1, minus 1. So again whole 1 minus of minus 1 becomes 2 square, and this becomes 0. 2 square plus 0 square is 4. It is equal to 4. Similarly, you can find for the remaining, similar to this this calculation, computation of Euclidean distance, square of Euclidean distance is similar to problem 6. So after computation of 8 distance square actually, so I got this one 4, 5, 13, 2, 1, 1, 5, 2. The thing here is they have given k is equal to 5. So we have to choose 5 nearest value. So 1, so I marked here. So starting from here, this is the one. So d5 is marked, corresponding y is also marked here, y label is also marked here. d6 is also 1, so this is also marked. And then we have 2. So we have selected 5 nearest neighbors. So so those are here D4, serial number 4, serial number 5. From the top I will come. So this is serial number 1, and then serial number 4, serial number 5, and then we have serial number 6, and then lastly serial number 8. So 5 nearest neighbors we have now, 1 2 3 4 5. So among these labels, 0 label, 1 label and 2 label for y, so we have already neighbors here. The number of neighbors having one label is more, therefore y is equal to 1. So the answer is option B, 1. Eighth one, you can see here, eighth one is options B and C. So B, K, NN regressor requires training data points during inference, and the C, K, NN regressor with a higher value of K is less prone to overfitting. So next one is ninth one. So what is ninth question? So ninth question, they have given which of the following statements regarding bias and variance is are correct. So regarding bias, so let us see first the formula for bias. It is f of x minus expected value of estimate of f of x, cap means estimate, and the variance is expected value of the estimate f of x minus the expected value of estimate square. So if you look at these two formula, so these two are not correct. Either one is correct or the other is wrong. So then we will see what are the options. Coming to the relationship between bias and variance, in the case of let us see for first one, overfitting. So in the case of overfit, variance is high, bias is low. So options are C and D. So in the case of underfit, variance is low, bias is high. So C and E are the options. C, low bias, high variance. So low bias, this is low bias, high variance, overfit. So next E, low variance, high bias. So low variance, this is low variance, high bias, underfit. So options C and E. Last one, suppose that we train two kinds of regression models corresponding to the following equations. Which of the following statements is are correct? So the answer for this option C and D. Options C and D. Okay. Thank you, viewers. Options C and D. Options C and D. Verify C and D. So A, B, C, D. Okay. Submit. Thank you, viewers. Thank you.